Here is a problem about change of momentum leading on to impulse and force. A ball of mass 0.5 kilograms falls to the ground, and just before it strikes the ground it has a speed of 10 meters per second. It bounces with a speed of 8 meters per second. And we've got two things to find here. First of all, we have to determine the change of momentum of the ball. And after we find the change of momentum, we have to find the average force which the floor gave the ball in order that it bounce up the way if it was in contact with the floor for 0.3 seconds. Now, this is the classic change of momentum equal to impulse question. So our first problem to solve is to find the change of momentum. Now, I strongly advise you to draw a picture of what happens. And here's the picture here like that. So the first thing we have to do is work out the momentum before and the momentum afterwards. And that's quite simple to do, because all we have to do is work out the momentum before, which is P, and we'll give it a symbol of B, meaning momentum before, and it's just simply equal to the mass times the velocity. But you have to be very careful because momentum is a vector, so therefore the 10 meters per second down the way must be minus 10. So we've got mass times velocity, so we've got 0.5 for the mass, times, and remember it's going to be minus 10 meters per second. And that's going to give you an answer of minus 5 kilogram meter per second. That's going to be the momentum before the collision. Now, what about the momentum after the collision? Well, the ball is moving upwards, so the momentum after the collision, PA, is easily found out. It's mv. So it's going to be equal to the mass, which doesn't change, 0.5. I'm going to multiply that by the velocity, which is going to be 8 meters per second upwards, which means we keep it as positive 8. So we get that answer there. So we get an answer of 4 kilogram meter per second. And that's us got the two momentums, the momentum before and the momentum afterwards. Okay, what's the change of momentum then? Well, the change of momentum is just simply equal to the following. Delta P, that's the symbol for change of momentum, is equal to the momentum afterwards. Take away the momentum before. That's going to give us a change of momentum. And that's going to be the same as 4 kilograms meters per second. Just put the kg in there. So it's going to be 4 kilograms meters per second. And we're going to take away, and be careful, bracket, a minus 5. That's the big problem which everybody faces. We have to take away the minus 5 meters per second. And you know that if you take away a minus number, it's the same as adding. So we get 4 plus 5, so we get 9 kilogram meter per second. So that's going to be the change of momentum. That's the change of momentum of that situation there. Now, once we know the change of momentum, we can equate that with the impulse. But remember, the change of momentum, delta P, is equal to the impulse given to the object. And the impulse is going to be Ft. So therefore, delta P, change of momentum, is equal to the impulse Ft. So what is the change of momentum? It's going to be 9 kilogram meters per second, and we change that to the impulse units. We get 9 newton seconds. That's the units for impulse. That equals the force times the time of contact, and the time of contact was 0.3 seconds. Therefore, we can find the average force given to the ball, and the average force F is going to be equal to the 9 newton seconds divided by our time of 0.3 seconds. You know the 2 seconds cancel out, and we'll get 9 divided by 0.3, which is going to be the same as 3 into 9 goes 3 times. It's going to be 30 newtons. And notice that the force is a positive force, which means the force is actually upwards. And that's what we expect, because the force is going to be giving the ball an upwards push to make it bounce up. So the key to this question is work out the change of momentum by simply drawing a diagram and taking the momentum before and momentum afterwards. Then do delta P. The change of momentum is the momentum after, take away momentum before, and we can get the 9 kilogram meters per second. And you have to be very careful because momentum is a vector, so you've got to take into account the minus sign. So when you take away a minus sign, it's the same as adding. We get 9 kilograms meters per second. Now we also know the change of momentum is actually equal to the impulse, and therefore the impulse we know is Ft, and therefore we can put down the change of momentum into the units of impulse. 9 Newton seconds is equal to F times the contact time, 0.3 seconds, and we end up with a simple equation to work out what the force which has been applied to the ball is an upward force from the floor of 30 newtons.